Hello everyone, welcome to another video. In this video we are going to discuss about Docker volumes and we will understand what's the importance of them, okay? But before we move on, let me first explain to you the layers that a container has in order for us to understand the importance of volumes. So I have this image here, which is not an image I created. I'll attach on this video a link to the source of this image. But this image showcases the layers that a container has, okay? So it has pretty much two types of layers by default. One type of layer which is non-writable, so therefore only read-only, and this layer, this read-only layer, is connected to the different image layers that you can have. Okay, pretty much when you create a Docker file, that Docker file has a bunch of instructions. Each instruction can generate a layer, and I'll create a separate video on this Docker layers. Okay. But pretty much you have a set of layers that are read-only. You cannot do anything as they are immutable and they are related to the images. But then you have a container layer that is read-write layer, okay? So you can read from it and you can write from it, okay? And this is the layer where, persistence becomes important in containers, okay? Because everything you write to this layer, if the container is deleted, this is like almost, let's say, in memory stored. If the container is deleted, you lose all the content that you've written on this layer, okay? This container layer, which is writable, meaning we can write to it, is supposed to be ephemeral, is supposed to exist only during the lifetime of the container. If you, as I said before, delete the container, this layer or the content of this layer should go away, okay? If this data is not persisted outside of the container, which is what we are going to see in this video, you will lose all the data you have here, okay? So the first bit of information that I think is relevant for you to understand is that anything that is written inside the container should be treated as ephemeral. So if you destroy the container, you can potentially lose the data if you don't store it somewhere else outside of the container, okay? So, and how can you do this? By this I mean not lose the data when you delete the container and so on. This is where the persistence comes in handy, and volumes and bind mounts, which is what we're going to discuss in this video. I'll just generally call it volumes, but you get the point. The point is that you avoid losing data on the container if you store that data outside of the container, okay? And using volumes and bind mounts are just a way to achieve this, okay? But before we go into details what volumes are and bind mounts are, let me first show you this concept in practice, that a container is ephemeral and all the data stored in it will be lost as soon as you delete the container, okay? So let me remove this image, okay, so that we have a bit of more of screen. And now let's see these concepts in action, okay? So I will run now a simple container just for us to showcase this persistence or ephemeralness of the container, if you will. So let's run a simple Nginx container. So I'll use Nginx throughout this video because it's easier for me to show you the persistence concepts. But let's just run a simple Nginx container and run a bash command on it, okay? And I'm inside the container. So if I by chance create a folder called app, go inside app, and inside app, let's need to echo hello and put it in a.txt. Okay, just pretty much I'm creating an a.txt file with this content. And if I do cat a.txt file, you can see that the content of this file is indeed hello. As a reminder, I'm doing this right here. So I'm writing data to the container, and that's being written on this writable layer. It's not being persisted anywhere outside of the container, okay? So what happens if now I come here and I already have a command pre-prepared, so this command will pretty much remove all the containers, okay, that I have running, okay? So what happens if I just remove this container? Just to show you, I have nothing running. So what happens, so I remove the container. What happens if I run the command again to start the container? What should you expect to see on that /app folder, okay? So first of all, you'll notice that there's no /app folder here. So if I do /app, there's nothing, okay? And there's nothing because whatever I wrote here is now gone. It doesn't no longer exist because it was not persisted outside of the container. So imagine that if you're writing logs to the container, or if you have a website that's storing images that the users upload to your site, imagine if you store those images in the container itself, and then the container goes down, or you delete the container for some reason. Okay, you lose all of that valuable data, okay? In your architectures in general, you should aim at having a stateless architecture, because a stateless architecture allows you to scale without having to worry about this distributed stores, okay? Having this distributed data, okay? So having that said, let's go out of the container. Let me run the force command again to remove everything. And I want to show you something else related to this ephemeralness of, I don't even know if this is a real word, but anyway. So you can actually force the containers to not have this writable layer here. Okay, let's assume you have a container that you just want to read data from. You don't want anyone to write data to that container, okay? So let me recover the command we did for Nginx. If you pass in the read-only flag, that will tell Docker to right away remove the access of the, or write access or write permissions to that layer. Okay, you no longer can do the write operation. You can still read stuff, but you cannot write stuff, okay? So let me show you this in action. Okay, so I'm inside the container. I can read stuff from the container. I can go to cd/home. Can see what's inside. In this case, there's nothing, or lib. Okay, so I can read stuff from the container. But the moment I do this /app, okay, I cannot. Okay, because I explicitly told Docker, hey, I want to remove the write access for that layer that you have, okay? So this small introduction just serves to show that containers, they should be ephemeral. They should be thought of something that you can easily just throw away, okay? And then can have another one back, and do not lose data on it, okay? So now that we've actually had the practice of looking inside the containers and seeing that you cannot create stuff, or you can create stuff in some occasion, let's now see what this volumes and bind mounts is about. Okay, so let's first start with bind mounts. Okay, so bind mounts are just a way to map volumes manually from your local storage, as an example, inside your container. What does that mean? For example, let me create a folder here called bind, and inside bind I'll create an index.html. Okay, and I'll just create an h1 hello from bind. Okay, with bind mounts you are going to link or connect this folder here, or any folder, any path in your local machine, to your container. Okay, effectively doing that link manually by yourself. This means that it's your responsibility to manage this folder. Okay, you have to manually create, you have to manually know that this folder exists, and this folder is eventually going to map to something somewhere in a container. Docker does not manage this type of volume for you by default. Okay, so how do I create a bind volume? Well, the first step is to actually create it locally. So we just did that. Now you just come somewhere, create a folder, or use an already existing folder. And now you have to bind this volume that you have locally inside the container to some path. Okay, and how do you do that? Well, when you do docker run, and let me do -it just because I want to go inside the container and see the contents of the file that I'm going to map, in this case this index.html. So you have the option to do a -v. Okay, that -v will handle the volume mappings. Okay, now you are going to tell Docker the following: hey, map everything that is inside this bind folder, map everything inside this bind folder to some path inside the container. So everything you pass after this, it's going to be the path inside the container. Okay, so since we are using Nginx, the path, if I'm not mistaken, is /user/share/nginx/html. Okay, so that's the folder that you are going to pass your data inside of the Nginx container. Okay, and what does this mean in practice? This means in practice that the data that will be inside of this, okay, inside of this in the container, will be the same data that you have on this folder here. Okay, now let's see this in practice. Then let's continue with the rest of the command. Nginx, I will not give it a name, and let me just put bash. Okay, so if I go to cd/user/share/nginx/html, you will see here that I have an index.html. Okay, and if I do cat index.html, you will see that this HTML file has the same content as the one I have here. If I updated the HTML file and I do a cat, you will see here that the changes I do outside of the file, in this case in my file system, are reflected inside the container. We will look into this a bit more later on the video. And now in the same token, if I go here and do echo, I don't know, and do h2, so I don't know, high from inside the container, and we echo this into index.html. Okay, you'll see here high from inside the container. Even if I do, I don't know, touch a.txt, you would see here that automatically the file is available inside the container, but also outside of it, because on your bind mount, okay, because you have it locally. Okay, so therefore you can actually see when things are changed, and I can say hello in file. I don't know. And if I do cat a.txt, I can see the content here. So you can actually have this two-way communication, okay? So as I told you before, this bind mounts are something that you have to manage yourself, okay? It does not come for free with Docker, meaning that Docker does not manage those volumes for you. And you will see in a second how you can query the existing volumes. Okay, I can show you right now how it is. So Docker volume ls, okay, you can list all the volumes locally. You'll see that I have no volumes created, and this should be the volumes that are created and managed by Docker itself, okay, which we do not have one now because we manually created. Okay, actually there's a more verbose way to do this bind mount stuff, which I normally never personally use, but it goes something like docker run -- mount type equals bind source, and then you have the source path. So in this case will be source equals bind. Let's do like this. So -it source, it's bind, and then target equals /user /share /nginx /html. Okay, nginx bash. Okay, and if you go to cd /user /share /nginx /html and you ls, you will see the exact same contents as you would see if you do the -v. But I think we can all agree that using the -v flag is much more practical than having to know this monstrosity of C. It's not that much, but it's not practical at all, I would say. Okay, so when should you use something like a bind mount? I don't know, maybe if for very simple scenarios. Most people don't use this in production. For me, I think it's nice because I can have control on where my volumes are stored. And not only that, but sometimes when we are using Docker commands, sometimes we do Docker system prune, and we delete everything and we force it, and by forcing system prune you may delete the volumes, therefore you lose everything because it's if you don't use bind mounts, because bind mounts are not managed by Docker. But if you use volumes and are managed by Docker and you do a Docker system prune, you can have the risk of losing data. I think it's an interesting option to use bind mounts for those scenarios, and also in scenarios where, I don't know, I just want to have some local debug and use a container with Node.js to run as some server for testing and so on. And you don't want, for example, to have Node.js installed locally. So you bind all of your files and so on to the container that has Node.js and it can run your server. So there are some scenarios where bind bounds can be useful. But yeah, just know that for me, one of the downsides is that you have to manage it yourself, and you have to know where those volumes are mapped to in the container, okay? Another thing that you will see as far as bind mounts is something called consistency. So as I've showed you here before, whenever I did a change inside the container, that change was pretty much instantly reflected on my file system. Okay, so whenever I did some change internally in the container, you could automatically see those changes from outside the container. Okay, this is because by default, when you create this volume here, we have a hidden option, which is the consistency model. Okay, the consistency model by default is consistent. Okay, this means that any change I do on the outside of the container as well as inside of the container will be automatically synced to the other place. So if I do a change outside of the container in one of these files, this will automatically be synced inside the container. Okay, so let's call it the atomicity of the operation. It's not the correct term, but think of it as database operation, right? So if I do an operation, for me that operation is completed when the sync is done inside the container, okay? And vice versa, if the change is done on a container, the priority is to have it consistent in the file system. So you also always have this operation of syncing immediately to the host system. This, of course, is a bit slow. So performance-wise, it's not the most optimal, but it's the default. I never changed this, to be honest, but keep in mind that you can also do this. The other mode that you have is called delegated. Okay. And on this mode, what matters, or the viewpoint that matters, is the container viewpoint. Okay, so every change you do inside of the container does not automatically propagate to the host system. Okay, it's not synchronously transmitted to the host system, but rather you do that asynchronously. Okay, therefore is a bit more efficient. This is a good option to have if your container writes a lot of data, but the host system reads less than the container writes. Okay, so maybe it will be a bit hard to simulate this because we have a very simple use case here. But if I go to /user/share/nginx HTML, and if I do echo, I don't know, a to b.txt, I know, maybe you can see some delay regarding this operation, okay? If you had it like, I don't know, if you had it like consistent, maybe that was not as quick. And share nginx HTML, I don't know. Sometimes it's hard to to have or to test this on the fly. It's actually so to the I put the it's actually also have the same delay even if it's consistent. Yeah, sometimes it's hard to test all of these modes, but keep in mind that the consistent one prioritizes the synchronicity, so it makes sure that the host and the container are synchronous. The delegated option that we had before, this prioritizes the point of view of the container. This means that the writes will happen on the container and then it will asynchronously propagate to the host system. It's a good option if the container writes a lot, but the host reads less. The other option, which prioritizes the point of view of the host system, is called cached, and it's the other way around. So every change that you do inside of here, so let's go to cd user share nginx HTML. So in this case, every change we do on the host system, like etxt, will first write inside of the host, and then asynchronously those changes will be propagated into the container. Okay. Again, this is a good option if you write a lot of files on the host system, or the files they change a lot in the host system, but not so much. The container is it's mostly read-only. As an example, I told you an example before. If you want to use your host system as an IDE, let's say, and then you have your container that serves as the server to run those files. Okay, maybe you would want to use this cached. But you have these three options as far as consistency of operation goes. Again, those will directly impact the performance of the persistent operation. Okay. And that's all I wanted to share about bind mounts. Okay. Now let's see the other paradigm, which is the volumes. Okay. Volumes, they like bind mounts, they are a way that you can persist data outside of the container. But the big difference is that volumes, they are automatically managed by Docker. Okay, you don't have to worry about knowing where those volumes are stored, how they are managed behind the scenes, and so on. You have the disadvantage that I told you before, that you can accidentally delete them, and because they are managed by Docker, you can lose all of that data if you don't have any backups. But it's convenient, in the sense that you don't have to manage it yourself. Okay. So let's start with this Docker volumes, the volumes part. There are two ways that you can create volumes in Docker. Okay, you can either manually create it, or you can let Docker run them for you or create them for you automatically. Okay, let's first start with the manual creation. Okay, so I already told you before how to list or look for Docker volumes. Okay, you can do this Docker volume ls. To create one manually, you just have to do Docker volume create and some volume name. Okay, let's call it my vol. Okay, and if we do Docker volume ls, we should see that this volume has indeed been created. Okay, you should notice here that we have this local driver. Okay, this means that this is mounted locally on our host system, but beware that you can have drivers that can mount this volume into, for example, a cloud provider of some kind. Okay, so you don't necessarily always have to have this driver as local, but In this case, we do have because it's being stored or mounted locally. Okay. So can I check the details of this volume? We can with the command docker volume inspect and then the volume name, in this case my vol. Okay. We can see a bunch of things. The date it was created, the driver we are using, some labels, and technically the path on which Docker is going to mount this volume. Okay. Now, technically, when you use this kind of volume, you don't necessarily care where this data is being stored. You just want the volume to exist. You just want data to be persistent. That's it. Okay. You don't want to know anything else. But we can actually see in Linux, this will actually be stored on this location, but on Mac and Windows, because we normally tend to use virtual machines, okay, of some sort. Technically, this path should be the path inside our virtual machines. I can actually, since I'm using Windows, I can actually check the content of this directory. Okay. So if I open a WSL entry here and I do sudo ls and this path, okay, you will actually see that I don't have this volume that I was told here, okay, by Docker. Okay, this volume should exist here. Okay, I should have here a folder called my vol, but I don't. Okay. So if you're using Linux, definitely you should have this. But as I told you, Mac and Windows, there's VMs, there's abstractions in the middle. At least for Windows and for all of this WSL workaround, no longer you can see this on this path, but rather there's another path that you can see called, and I have here the path prepared, just to be easier to type. So this is the path in the new versions of Docker Desktop that it's used. I'm using Docker Desktop locally. So this is the path where you can actually see the folder that was created, okay? And maybe inside of this, of my vol, you can see this underscore data, okay, which is the data that when we did Docker inspect, okay, we should see the data inside of this. I don't have anything here because I have no data mapped yet because I just manually created a volume. But once we actually have this data, we will come back to this and we will actually see the data here, okay? So let's just have a step back, Docker volume ls, and see we have a volume, okay? But now I want to map this volume to some specific folder or directory in the container where I want the data to be stored outside of the container, okay? Keep in mind, the point is to have a path in the container where we normally write data to, okay? As a reminder, we want a path in this container layer that normally we write data to. This path has to exist outside of the container because otherwise any data we write to this layer will be lost. So as I said before, now the idea would be to map this volume I just created called my volume to a specific path in a container. In this case, I'll use nginx again because we have that index HTML. So if I do docker run and use this -it option, or maybe I just don't use -it and we just see the data on that volume itself. So if I do docker run and I can give a name to the container, but I won't. But I'll just do the -v option again, because that's the option or flag we use to map volumes. And in this case, I don't have a /myvol, because this is not a folder locally, but rather a volume that is mapped by Docker. In this case, I have to use the name I gave my volume. Okay, in this case, my vol. And I'll map it into a folder inside the container, or a directory inside the container, and it's user share nginx html. Okay. And nginx, and yeah, I think that's it. We can actually do a -p just to see this in action from outside. 8085 80. Okay, something like this. Let me do this here. Okay, -v, like this. Okay, and -d for detached mode. Okay. So if I open the browser preview, I have this browser preview, and I go to http:///localhost 8085. You should see here that I have my page welcome to nginx. Okay, that's from my running container. And now what happens if we redo this ls on the data folder? Okay, we should see this this content with this index.html, which maps to this index here. Okay, so yeah, as you can see, these volumes, okay, we did not touch any of it. Okay, it was automatically created by Docker, and Docker manages it. Okay, and you can see the content of this here. Okay, most people like to use this option in production just because it's more practical, it's more convenient, I would say. Even though I have personally my options on it, I personally like bind mounts better because I have more control over it. But beware that probably 90% or 95% of people like more this volumes option. Okay. Now I told you that there is a way to map this manually. That's what we did. We first created the volume, and then we attach it to a container. Now let me list again all of this. Okay, still have one volume, but there's a way where we can do this. Let me put here another port, 8087. If you create a name here, or you attach a name here on the -v option that doesn't exist on Docker volume, or when you do Docker volume ls, Docker will automatically create this volume for you. Okay. Okay, what happens if we do Docker volume ls? See this, the volume is automatically created, and if I go to 8087, we should be able to see this. Okay? So even if I refresh the view, okay, you should be able to see this here. Okay. So yeah, no, that's pretty much what you have to know about Docker volumes. Of course, there are ways. You can also I showed you another way to inspect. So if we inspect Docker volume, inspect the new one that was automatically created. No, not this one. So here, you should also see the properties that it has. I mean, it's pretty much the same as the other one, except for the name and the time it was created. Okay. But keep in mind that those volumes are automatically created by Docker. Now comes the funny part, which is what happens if I delete the container. Okay, we didn't do this demo on the bind mounts, but the effect is the same here because the data is persisted outside of the container. So I have a bunch of running containers. Okay, what happens if I delete them? Okay, if I delete them, okay, they are out. You have no containers. What happens if I shouldn't have done this, but let me do something else. Let me use this minus option, minus IT option, and let me go in Nginx, and let me change the, oh, I forgot to do something else. Let me change the port to 8088. What am I doing wrong? Of course, I have this, let me do this, minus force. And let me not run it on detached, okay? And let me remove this bash here. So what happens if I go to /user/ share /nginx /index /html, sorry. Okay. So what happens if I do this? Okay, so echo h1 /h1 hello, and I put this content inside the index HTML. Okay. So what happens if I do this change, and you can see the content. I go exit the container. I remove the container. Okay. Container is out. What happens now? Okay. You can see that there is no containers. What happens now if I run this container again? What should I see on this index HTML? Okay. Well, if you remember on the first example we did where there was no volumes, the moment I deleted the container and started one again, I lost all the data. But because now I have volumes, the data that I wrote inside the container will be stored in the volumes. Therefore, nothing will be lost. So let's see this in action. So if I go to /user/ share /nginx HTML, and if I do cat index HTML, you'll actually see that the data I had there is still persistent. Okay, if I go to 8080, you should see here this h1 hello here. Okay, or you do not see because I overwrote the process here to create the server actually. So if I just exit out and I run this as detached, ignoring the minus IT, give it a port of 8089, and have this running here, you should see hello. Okay. So indeed, with volumes, not only you have the ability to store data outside the container, but you have this resiliency gain where if the container goes down, it's deleted for some reason, and assuming the volume is not deleted, the data still persists. Okay, so data is not indeed lost. Okay. So you can do yourself the same example for bind mounts. It's exactly the same. So if you have a volume with bind mounts and you delete the container, actually we saw this indirectly when I recreated a bunch of Nginx containers, and then when I did an ls on that directory, you could already see the previous content that was here before. So indeed, we technically saw this indirectly, but I didn't do an explicit example. But the same value is true for bind mounts and volumes. If data is persistent in them, container is deleted when the container is restarted and the volumes are mapped. Okay, this is an important part. The volumes have to be mapped, otherwise, how would you know which data you should reuse when the container starts? So granted that those preconditions are there, the data should be there on the container when the container restarts, okay, or starts again. Okay, so this is in a high level overview what I wanted to share about volumes and persistence as an overall concept, but I'll reserve this last part of the video to speak about two things. One of them is some commands that might be useful when it comes to volume management. So as you know, Docker volume ls is used to list volumes. If you want to remove a specific volume, you can just do rm my vol. Okay, this will delete this volume. Let's see if I have a running container, but if you decide to delete this auto one, you cannot, because there are containers that are using it. So docker volume rm, okay, we'll delete the volume. We also saw docker volume inspect, right? Docker volume inspect, that will check the content of that, the more details about that volume. So, and yeah, that's pretty much some useful commands that you can have with Docker volumes. Now, there's also one question you might ask, which is, what about backups and restores? Okay, what happens if periodically I want to do a backup of my data? Okay, so let me do a minus force, okay, to remove everything. And now let me explain to you how to do a backup and how to do a restore. Okay, first let me create a backup folder here. Okay, you will see why that's useful in a second. So let's do this with the bind mounts, because that's going to be easier to handle or to see the effect of this. So how do you do a backup? Okay, so first thing that you have to know is that we use an image called BusyBox. It's a very simple, small image that we use because that image has some basic functionality that we need to do the backup and restore, namely a compression and decompression commands. And we just and you will see that we use the BusyBox image because the only thing we want to do is to have a container go up, to the restore, and then go down. Okay, once the restore or backup is done. So how do we do a backup? Well, we run this command. Okay, we remove the container as soon as it's not used anymore. And now I have to map, and this is the normal thing you would do anyway. So you have to map. You normally would map a volume to some folder inside of the container, right? So in this case, what we did before was we mapped the bind folder into a user share nginx HTML, right? This was something we did before. Now the backup part now comes in handy, and I have to do another volume map. And where do I want this backup data to be stored? Outside of the container, okay? In my backup folder, okay? I don't know, as we saw before, we don't want the backup data to be stored in the container, because if the container goes down, we lose everything. So we normally have a directory outside of the container where we do the backups on, okay? And so also, we not only have the place on the container where the data is normally stored. Okay, it can be we used this directory by default, but in this case, since we are using BusyBox, let's just have this /data directory as something specific or simpler, because we don't have that index HTML on BusyBox. We just want to have some dummy directory date, place where we are going to do this mapping. Okay, because normally this bind will already be mounted in some running Nginx container. Okay, and you would run this BusyBox as a sidecar or something in parallel. Okay, because if that running Nginx container, or any container you have for that matter, if it made any change to the data inside of that user / whatever path we saw, that change will be reflected in the bind folder as we saw before. And if it's reflected in the bind folder whenever I do the backup, those changes will be reflected on this /data inside this new container I'm building. So anyway, the backup data, I want it to be stored in this backup folder locally. And of course, I need to map it into some directory inside the container where we will actually first store the backup. And let's do in /backup. Okay. Now the image that I will use is BusyBox, okay, as it is a very simple, small image which fits the needs of our operation here. And the operation I will do is to create a let's say a compressed version of the data we want to back up. Okay, so I will do a tar, which is a command that is available here inside BusyBox. czf, okay, to compress and do all of this compression and zipping of the files. And I want you to put, and I'm telling the command to put the result of this compression and zipping inside the /backup folder, right? Which was the folder that we assigned manually. This can be anything you want. I created /backup for simplicity's sake. And I want this to be named backup.tar.gz. Okay. So I've specified the directory where I want the backup to be stored on, but what is the source for that backup? Okay. So I specified a -c to change directory. I want to change directory to /data, and I want everything inside the /data to be backed up. Okay, so this dots just, it's a telling that I want everything inside /data to be backed up. Okay, and if we run this command, one thing that we should observe is that inside this backup we have this backup tar gz. Okay, now let's run this command once again, because this is confusing. Okay, so we are interested in doing a backup. Okay, if I'm doing a backup, it means that I have some volume, either bind mount or not. Okay, this doesn't necessarily have to be a bind mount. This can be any volume, and that volume has data. Okay, if that volume has data, I can technically mount this volume to any directory inside any container. Okay, in this case we chose the BusyBox container or image because it's small and has this tar capability that we need for the backup. So I mounted this bind mount volume. Could have been a normal Docker volume. I mounted that volume inside this slash data, which means that whatever data is on this volume on the left will be on the volume on the right. This is what we've been doing so far as playing around with volumes and mappings. Okay? Now, I have this data there, but I want to do a backup from within the container, and I want the output of this backup to be visible from the outside of the container. Okay? And the easiest and probably the most common way is that you define a specific folder where you want this backup to be stored. In this case, I just created here on the root of where I'm working on. And since you're doing the backup inside the container, you normally need a directory to store this backup. Okay? And I just put it here, /backup. So, and if you use bind mounts, you would know that whatever data you put on this /backup will be automatically reflected on outside the container. Okay? And by doing this tar command, you are effectively telling it, okay, everything that is inside of /data, which therefore is everything that is on the bind, okay, everything that you have here, please do a backup of it. Okay? So it has this two-way communication always. The first is the data way. So this, think of it like two-way streets. Okay, I have the first street, which is the street of the data, where the data is flowing, which is the data I want to do the backup for. And then I have another street, which is the backup street, where the backups are coming from. Okay, and so, or lanes, okay, whatever the analogy you want to use, but effectively you have two ways. Okay. So by doing this, we can easily do the backup. Okay, now let's do the restore. Okay. So before we do the restore, let's see the volumes we have locally. Okay, I want to do the restore. First, let's do to a bind mount. Okay, and secondly, let's do this restore to the nginx container. Okay, so that we see this index HTML. Let me actually give it another name. Restored. Okay, so that we know that this is something new. Okay. So first, let's do the restore from this backup into a restore. Let's create here in the outside. Let's create a restore folder. Okay. So and let me again maybe redo this backup so that I get the new data, because I changed this index HTML. So let me indeed do this again, and hopefully this reflects the new changes. And now let's do the restore. Okay. Again, I'll use tar commands, and BusyBox is an image that is small enough that we can work for the restores. So if I do docker run --rm, because I don't want this BusyBox container to lay around after it's done. So first I want the volume. First let's select this. Which volume holds the backup? Okay, the volume that holds the backup is the /backup. Okay, and I want this volume to go inside the /backup of my container. This means that when this new BusyBox runs, already it has the backup inside of it. Okay, which means that from within the container we can do something with that restore. Okay. Then I have the restore here. Okay, I know that I need to have the data inside once I do the unzip, I need to have a directory where I want the unzip content to go to. Let's say this is /data. But how can this data be visible from the outside? Again, you can create a bind mount or just a normal volume. But right now, for this first step, let's say I want the restore data to go to the restore folder here. And I want this BusyBox again. And now I have to do the other way around. Okay, so I have to unzip it, let's say. For this, I'll run a shell command, and I'll say, okay, go to /data, which is the directory I've specified here. If you had put here potatoes, this will be cd/potato. Okay, and I want to unzip and decompress this restore I have. Okay, so I want to then you can look this command up. Okay, but I want to unzip to my backup directory, and I want this to be called restored dot what did I call it? I called it backup dot tar dot gz. Okay, so let's redo this command then. Okay, so I'm this is the place where the backup data is stored. Okay, locally it's stored on this backup folder, and this will map to a backup folder inside, or directory inside the container. Okay, now visualize, you're inside the container, you have this backup directory that has this zipped. Okay, now you need to have a directory where the data will be unzipped to. Okay, inside the container we called it /data, but you don't want this data to be only inside the container. You want this data to be visible from the outside of this container, and in this case we created a bind mount so that the restore is stored inside of this folder here. And now when you start BusyBox, I'm just running a command that states, okay, unzip inside /data everything that you had in /backup tar gz. Why is this name here? That's because I've named it like this when I did the backup, and when I did the mount, I mounted inside /backup. If this was /potato, this will be /potato backup tar, whatever name you gave it. And if you do this inside /restore, you should be able to see the content. Okay, you can even see here the restored thing here. Okay, now let me restore this not to a bind mount, but rather to, let's call it restored nginx font. Okay, and now my keyboard is all messed up. Let me fix this. Okay. And now if you do docker volume ls, you should see here that I have a new created volume that was automatically created, as I told you before, by Docker. Now, what happens now if I do docker run, but not BusyBox? Let's run the command ourselves. It's easier to explain. So if you do docker volume ls, you should see that we have this new volume that contains the restored data. Now what happens if I do docker run? Let's run it detached so that we can see the content. So what happens if I do -d, -p, let's have it in 8090, 80, okay, -v. Now I will map this data, which is the volume that I just restored, could have been this /restore here, if you wanted to use a bind mount, /user /share /nginx /html nginx. Okay, so what happens if I now go to http localhost /8090? Okay, you should expect to see the HTML that was restored. Okay, indeed, if you do docker ps and you do docker exec -it this container bash, and if you go to /user /share nginx html and you do ls, you should see the contents that were recovered from that first operation. Okay, so and that's how you effectively do a restore. Okay, so hopefully you now know it's a bit confused, so maybe you have to do a bit of practice to understand how this two-way communication works in the backup and the restore. It was confusing to me first when I first looked at this, but now it's a bit okay. But just give it some practice and you'll see that this will work out. Okay, well, that was it. That was all I wanted to share on this small introduction to Docker volumes or persistence as an overall topic. Thank you so much for watching, and I'll see you in the next one. Bye.